In the previous video, we saw how to leverage CDNs to be used within the UI so that we can independently scale our images and media specific data without getting more load to our UI service. In this particular video, we are going to look at the different trade-offs between the database and the cache because we are going to build some backend services. I'm going to discuss some of the basics of how you can scale a database, how we can scale that using a cache. We are going to look at the trade-offs and we are going to decide which one to use. Also, we are going to overlay that with the reviews and ratings architecture from Flipkart. Flipkart has created a blog post on that. I'll walk you through the exact blog post. I will explain what they have mentioned. Also, we will see how did they scale that architecture with respect to data, because data is the key in terms of scaling. So we are going to look at that. Finally, we will look at some of the learnings from Flipkart and also what's next for the reviews and ratings architecture within the Flipkart ecosystem. With that, let's get started. In order to scale the backend systems, usually we have auto scaling capabilities defined within the ecosystem. So if let's say there are too many traffic coming to the UI service, we can automatically scale our instances or you can scale down. In case of flash sales, during the flash sale, we can have hot scaling capabilities. So there are hot caches or hot instances which are already pre-built. They are scheduled to be auto scaled during the event. So for example, if let's say UI service has 8 instances running in normal day, during the flash sale, we might exceed 40 instances or 50 instances, so that we have these instances running already so that we don't get any latency in terms of requests coming in during the midnight when the flash sale opens, right? So that's where the hot instances helps scale the backend services. In addition to that, all the requests will be routed to the internal systems, right? So the UI service is the front facing service which gets all the traffic, and it gets these traffic and then routes to internal systems. Let's say we have a product service, all the traffics are going to be coming to the UI service, and then the products are going to be pulled from the database, right? The database here I'm primarily using is a PostgreSQL. You can use MySQL as well, depending on the use case. I'll talk about why we are using it. In order to add resiliency to the database, I will have a primary and the secondary instance, so that if the primary goes down, secondary helps in giving traffic or making the database resilient. Now, since that more traffic is getting pumped in into the UI service, we also can scale our product service to match or maybe reduce the number of instances depending on the type of traffic we expect. In our case, we expect the same kind of traffic which the UI service expects, because product service is the key for getting all the product information within a flash sale, right? Because everything revolves around the product. So every UI service call will go through the product and get the list of products from the database. Now, since we have scaled the backend services based on hot instances or cold instances or maybe auto scaling, how do we scale the data? Right now, we have only one database right now, which is the primary database. All my connections are going to the primary database. Now, how do we scale that? There is one option which is called read replicas, using which you can scale the read side, because users are going to just read the data, right? In this case, when I want to look at a product, I just read what product information is there for that particular product. I don't do any writes here. I can create read replicas for the database. So whatever gets added into the primary instance gets replicated to these instances, and those are propagated to the corresponding backend instances which we are using. So there will be a load balancer based routing logic between the product service and the database and the read replica. So you can do that as well. That is one option. Why we went with the read replica is we know that the products can be added only by the products admin, which is a separate service, which will be controlled by the admin UI, which is controlled by few set of users, right? So not all of us can add products, right? I mean, only internal folks can add products, or maybe some vendors can add products. That traffic is going to be less compared to the traffic which we expect from the users. So what we can do is we can have separate product admin which will be writing data into the database, and those can be replicated into read replica so that we can send that data to the user. This is one way of scaling the database or the data. There is one more way where we can build caches. Instead of having a read replica, we can build caches, a distributed cache, using which you can give a time to live for each product. So if let's say I access iPhone 13 to be bought, so iPhone 13 will be stored in the cache. There will be a time to live associated with iPhone 13. Let's say the time to live is 1 hour. Now within 1 hour, if somebody else hits the iPhone 13, again the time will be extended. That's how the caches work, right? So you can either use a cache or you can use a read replica. Now, how do we choose between this cache and the read replica? Let's understand some of these trade-offs. Let's say the database holds 200 gigs of data. This 200 gigs is product specific information. If I use a read replica, all those 200 gigs are replicated to all the instances. Now the space constraint will be high because I have the same data getting replicated to all the instances. So there is 200 gig, 200 gig, 200 gig everywhere, right? But in terms of caches, when I build a cache, I can restrict the amount of data I want to store within a cache. If I, let's say, envision more traffic, I can increment that particular size, or I can add more caches into the distributed cluster. So there is some flexibility in terms of using a cache, and also caches have time to live. So the space will be like 50 gig, and then if, let's say, the space got exhausted, then the oldest record in the cache gets terminated or cleaned up, and then the new record gets added. So caches are efficiently managed when you want to reduce the size and the cost. And of course, caches are faster than the databases, though they are read replicas. Caches tend to be more faster than the read replicas because they function at one level higher. Now, coming back to the technology which we can use, or which Flipkart uses Aerospike for storing the product information. It also uses Redis, the key value store, for storing all the caching information. It also uses MySQL for storing ratings and review. I will show that in the next slide. In the next slide, we are going to go in depth about the architecture of reviews and ratings. But before that, let's look at high level what they do, right? There's also a caffeine. Caffeine is an in-memory cache which you can use within the JVM. If you have all these caffeines defined in your individual application containers, the caffeine cache sits next to the application, and the latency between the application and the cache is much more less than compared to the latency between the product service and the caches, which is distributed cache or the database. So there are some metadata which you can store within the in-memory cache within the database. If you don't know what are the different caching architectures, I have made a separate video on caching architectures. There are tons of architectural styles within the caching architecture. You can take a look at that. So this is one style. So we can have a separate container, a sidecar, which is running with the application, which is running on caffeine, and you can use that as an in-memory cache as well. Also, in order to reduce the size of the data, because there is going to be more reads from the cache, so we can encode the data into a binary format like protobuf or avro to store it in the key value store. So Flipkart uses avro to store the data type. They convert everything into a binary, use the avro format, and then store it in the key value store. Let's look at about all these tools and frameworks how Flipkart uses within the ratings and reviews architecture. So what is R&R, right? R&R is basically reviews and ratings. That's a separate team and separate system within Flipkart. Recently, they published a blog post. If you want to take a look at the blog post, I have the links in the description below. You can go and take a look at them, read them in depth. But I am going to summarize what they have discussed in in that particular blog. Flipkart uses CQRS pattern, command query resource segregation. If you don't know what is CQRS pattern, you can take a look at my video on CQRS, where I have explained a trading system built using CQRS. I'll also explain that in a bit here. They also use RDBMS, which is MySQL. They store all the review information within MySQL database. You might be surprised, but I'll tell you why they are using it. They also use a key value store for scaling that as a caching system. This is the architecture of the reviews and rating system. Whenever a reviewer writes information into the database, the reviews or the number of writes are going to be much more lesser compared to the number of reads. That's the major reason why Flipkart shows CQRS as a pattern, because the number of people who write reviews or the number of requests which are coming in to be written into the database are going to be much lesser. So you can segregate the requests per second in terms of reads and writes so that you can independently scale your reads with respect to RPS. So if you see here in this diagram, there is a product reviewer who writes reviews. Flipkart uses MySQL to store the data, and then it goes through moderation process where people go and approve that particular review, and then they are ranked, and then they are added to the product. Now, how does this gets displayed in the product review is we push the data, Flipkart pushes that data into the Aerospike and the Redis clusters, which are maintained as a cache. So the reviews or the actual reviews reside in the MySQL database. However, for people to be viewed, they get the traffic via the Redis or the Aerospike clusters. So lot of people read product information reviews, so those traffics are segregated from the writes. So even if, let's say, the write is down, your reads are not failing or not affected. This is at a high level on the architecture of the reviews and ratings. Let's go through how they stored the data so that they can make it read faster, because even with that architecture we tend to be slower because of the traffic which we receive. So what Flipkart did is Flipkart went through different process called as data cleanup, serialization, compression, and deduplication. These are different data specific operations which Flipkart took in order to improve the efficiency or the latency or the throughput of the application. Now, what did they do as a part of the data cleanup is they removed unwanted fields in the data. Generally, what happens, we tend to process more and more fields. However, when we read these fields, there is more chances that the data size is huge. Your read request goes through more cycle. It has more data. So the transfer logic again has more data. So this adds up to the overall end-to-end latency for every request. So they reduced the number of fields which they want to read. So that is how they restricted the data cleanup activity. In terms of serialization, to do serialization and deserialization every single time, if you look at Flipkart's data, is having a predefined or a fixed schema. So the reviews and ratings has a fixed schema. So the schema can be segregated from the data. So Flipkart is using a format called Avro, which is similar to Protobuf. What Avro does is it converts your JSON into a binary format, and you can use that binary format to send the data across systems. You can use that to serialize and deserialize data, and the serialization will be much faster because these are stored in the form of binary data. That's where data compression also helps improving the binary data, because using abbreviations, if you use shorter text, that will help us in reducing the data size, and when we are reading them and deserializing them, it will be much faster. Flipkart uses data compression algorithms like Shako and Snappy. These are different algorithms to convert longer fields into shorter fields, and then you can decode them. That way the data size or the format is like much shorter. Finally, deduplication is sorted by using caches so that we don't have multiple replication copies. Obviously, everything is rendered via the caching layer. There are different caching layers in Flipkart. They use Caffeine in the JVM layer. They use Redis as a key value store, and they also use Aerospike, where they have filtered out all the data and then they have just pushed all those data into Aerospike. So if you don't know what is Aerospike, Aerospike is a data platform. It supports all types of database models. Earlier, it used to support only key value store and NoSQL type of models, but nowadays it started supporting key value store, document, SQL graph, and also time series data. Flipkart heavily uses Aerospike for all the product specific information, storing them and then retrieving them for the UI. In addition to that, it also leverages Redis for the caching layer. This is how Flipkart scaled the reviews and rating system with respect to data. So it's not just about scaling and adding more servers, but it is also to do with the data, about cleaning, serializing, compressing, and deduplicating the data. So that way we can reduce the latency and get more throughput during flash sales. Coming to the learnings on what Flipkart learned from the whole exercise, Flipkart said that encoding the data in the binary format helped them reduce the data size, but it also helped them to reduce the compute size required in order to serialize and deserialize the data. This helped them to convert the message from a binary format to the JSON format much faster, and also while transferring, when they transferred via the binary format, it was giving better performance than the JSON strings. Flipkart also started using enums up as opposed to strings, so that they can efficiently store different data types in a different way, so that they get right precision while storing decimals as well. Also, they started using UUID as bytes, because generally we create UUID and store them as strings. Storing UUIDs as bytes helps us save the space, and also it helps us in reading data faster and writing data faster. Also, they understood that the compression algorithm which we use for one particular data type may not work for all the data types. So you may have to look at different specific data and then choose which data type and which compression algorithm to use there. Also, they do relook at the data periodically, so that they can go and clean up and optimize the data whenever there is unused data in the system. These are the different learnings which Flipkart has come up as a part of the whole reviews and ratings architecture on their exercise in the last few years. Finally, what's next for the RNR? So as I mentioned, Flipkart has Caffeine used as an in-memory data store within the application. So whenever an application comes up, the cache needs to be loaded. So individual containers, when they come up, the cache needs to be loaded. That's where cold start comes in, right? When we scale the services one by one, and when we add more instances into the existing fleet, your cache also needs to be populated. So since Caffeine is an in-memory cache, whenever an application spins up, there is also a Caffeine instance or the Caffeine cache created, right? So you will have to load the cache. Now Flipkart wants to handle that in terms of aggressively loading the cache so that they can reduce the latency during the startup time. Right now, if a new instance gets spinned up, the cache gets some time to load, and then that's how the traffic is served. That's why they do a lot of hot instances. So they do schedule instances and they spin up instances beforehand, but they want to go into mode where cold starts are much faster. That way they reduce the latencies. The other challenge is, since the data between the individual application caches, which is the caffeine, and also the Redis, right? These are two different caches. Now, there needs to be a way to refresh the application container with the data which is coming from the Redis cache. So Flipkart is working on a pub sub kind of model so that caches are notified so that the caches can go and refresh the application containers to go and get the same data from the cache, from the Redis cache or the Redis clusters. So Flipkart is still working on that kind of a system. And finally, when we build a hot, warm, cold layer where some of the instances are pre-built, they are hot, and then things are getting read from those instances. Some of the systems are cold in the sense they can be spinned up any number of times. So we don't have to load all the data into distributed cache. That's where Flipkart is working on making that efficient so that they can reduce the number of data getting loaded. For example, they have a lot of language specific information like English, Hindi, and there are other languages as well, right? They wanted to have an efficient way of managing the data while loading them into the cache. So they don't want to load all the languages into the cache. Instead, they will just load English and Hindi because those are predominant and they can be loaded much faster. So Flipkart is working on a strategy to solve that particular problem as well. I'll just summarize what we just discussed in this particular video. Initially, we scaled the UI service using the CDN in the last video. So we have flipkart.com. For the UI service to load images, we will be using a CDN. Using the object store, we can synchronize data from our object store to the CDN's object store. All the images are loaded via the CDNs using edge locations from different tier 1, tier 2 cities. In order to scale our products and the rating service, UI service can be individually scaled. They can auto scale up, auto scale down. Same way product services can be auto scaled up, scaled down. Same way with the review and the rating service. In order to scale the data, we use RDBMS like MySQL or Postgres to store all the product information and the review information. They get compressed and cleaned up into the Aerospike cluster. There is also a Redis cache built on top of it. Using this distributed cache, the data is getting pushed into the products and the review ratings. This is how the data is scaled at the backend service. I hope you are able to understand how we can leverage caches to scale our data, and also how we can leverage compression and encoding techniques to reduce the size of the data and also to make our reads and writes faster. If you want to go through the blog post, this is the blog post which I was mentioning. So all the information I just mentioned, there are more detailed information about individual data formats, etc. You can take a look at it. There are two parts to this blog, so I've just summarized them in the single video. In the next video, we will look at the infrastructure scaling part of how we can scale the infrastructure. We will also look at the communication between microservices, card service, and payment service. So there are more topics to be discussed further. Meet you in the next video.